Good morning to all the students. Today topic is NMR spectroscopy. NMR spectroscopy. The NMR stands for the nuclear magnetic resonance spectroscopy, and the NMR spectroscopy was introduced by three scientists, the Felix Bloch, Edward Purcell in 1946, and is important tool for the structural elucidation of the organic substance. And the NMR spectroscopy is divided into number of subfields depending upon the magnetic nucleus being examined. For example, this proton magnetic resonance spectroscopy, this proton magnetic resonance, or this H1 NMR, the carbon 13 NMR, this fluorine 19 NMR, and this phosphorus 31 NMR. So discuss about only this proton NMR. What is NMR? NMR is a phenomenon which occur when certain nuclei of an atom are placed in a static magnetic field and exposed to second magnetic field. And in principle, the NMR is applicable only to the nucleus possessing spins. In other words, the transition of a nucleus from one spin state to another spin state with the resultant absorption of the electromagnetic radiations, they are placed in the external magnetic field, that is called the NMR. And NMR are observed in radio frequency region. Next is the magnetic property. The magnetic property of nuclei like electrons, that is the nuclear particles such as proton and neutrons are considered to spin about their axis, and nuclei in which the spin of the nuclear particle are not paired, the nucleus as a whole will have resultant nuclear spin quantum number, this I, and some nuclei have integral value, that is I equal to 1, 2, 3, 4, 5 and so on, and some nuclei have fractional value, that is I equal to 1/2, 3/2, 5/2, etc. and few nuclei have I equal to 0, that is the nuclear spin quantum number is 0, that is the carbon 12, this oxygen 16 and this sulfur 32. These nuclei have nuclear spin equal to 0 and that is are called non-magnetic. And the numerical value of I, nuclear spin quantum number, depend upon the number of proton having parallel or anti-parallel orientations and its relation with the atomic number or mass number, the mass number and that is atomic number, and this I nuclear spin quantum number. अगर even nuclei है, even mass number है, even atomic number है, तो I की वैल्यू होती है 0, this nuclear spin quantum number equal to 0. अगर odd mass number है, odd atomic number है, इसकी I की वैल्यू होती है दैट इज 1/2, 3/2, 5/2 एंड सो ऑन। अगर इवन मास नंबर है और ओड एटॉमिक नंबर है तो I की वैल्यू होती है इंटीग्रल वैल्यू 1, 2, 3, 4, 5 एंड सो ऑन। Next is spin active nuclei. Spin active nuclei behave as spinning nuclear magnets or tiny bar magnets. The tiny bar magnets, spin active nuclei such as proton, behave if it were spinning about an axis, like the gyroscopic motion or the earth spinning about an axis, and these spinning nuclei produce the external magnetic field around them and behave as spinning nuclear magnets. Next is principle of NMR spectroscopy. The orientation of spinning nuclear magnets in a uniform magnetic field and energy description in NMR phenomena. This is about orientation of spinning nuclear magnets. These are the spinning nuclear magnets. These are spinning nuclear magnets. These are nuclear spinning magnets, and in absence of the external magnetic field, these spinning magnets ally random in their atomic or molecular environment, but when placed in a uniform strong magnetic field, this is H naught, is the strength of the applied magnetic field, and when these nuclear magnets placed in a strong uniform magnetic field, these nuclear magnets align their own field either with the applied magnetic field or against the applied magnetic field, giving rise to two separate energy states. This is the alpha spin state and this is beta spin state, and this is the energy difference, that is delta E is the energy difference, and I is this plus half and this I this minus half. For example, the proton, when they are placed in a uniform magnetic field, so proton may be aligned with the applied magnetic field or against the applied magnetic field, and two possible orientation do not have same energy. In the lower energy state, the fields are aligned with each other, that is the parallel orientations, and in higher energy state the fields are aligned with against each other, this is the anti-parallel orientations, and the parallel orientation is more stable about small amount of energy, and energy difference between these two states correspond to the frequency of the radio waves. This is the principle of the NMR spectroscopy. अगर ग्राफिकली देखें, this is the H naught, the strength of the applied magnetic field, this is the energy, and the delta E equal to 0, here the delta E equal to 1, and here this is delta E2 and delta E2 greater than delta E1. That is, the value of delta is very small, but its magnitude varies with the strength of the applied magnetic field. If there is no field, this H equal to 0. अगर strength of applied magnetic field 0 है तो delta E equal to 0. So two spin state have the equal energy, and when the nuclei are placed in a uniform placed in electromagnetic radiations, and the flipping of the nuclei from lower state to higher state take place by absorption of energy, and nuclei are said to be in resonance with electromagnetic radiations, and field of spectroscopy is known as this NMR, nuclear magnetic resonance spectroscopy. And the nuclei placed in external magnetic field having two orientation, the energy difference delta E equal to h nu, and this is gamma h naught h upon 2 pi. तो न्यू हम निकालेंगे, न्यू इक्वल टू दिस गामा h naught upon 2 pi. The h naught is the strength of the applied magnetic field, nu is the frequency, and gamma is gyromagnetic ratio, that is the ratio of this angular momentum, magnetic moment divided by angular momentum, and for each proton the value for gyromagnetic ratio is 67570. This is the value of gyromagnetic constant, and we can say from this equations कि frequency directly proportional to h naught. From this equation, for example, अगर applied magnetic field h naught equal to 14100 Gauss है, and this ratio निकालें, frequency निकालें, तो this gamma 67570 multiplied by this 14100 upon this 2 multiplied by 22/7, तो ये जो आता है 60 10 की पावर 6 hertz, that is 60 megahertz. That is this from this relation, the higher the applied magnetic field and the higher the frequency of radiation to flip the proton from lower state to higher energy state, and this is the principles, and the unit of the applied magnetic field is Gauss, and 1 Tesla जो होता है SI सिस्टम के अंदर इसकी यूनिट टेस्ला होती है 10 की पावर 4 Gauss. This is the relation between about Tesla and Gauss. These are the units, SI units of magnetic field strength. SI system में टेस्ला होती है और CG system में Gauss होती है. This about the principle of the NMR spectroscopy.